Hello, we're going to talk about using similar shapes. Indirect measurement is the process of using similar shapes and proportions to find a measure. When you see that two shapes are similar, it will list that they are similar and use a little squiggly line. For example, it may look like this. Triangle ABC is similar to triangle DEF. If you know that two figures are similar, you can use proportions to find unknown lengths of sides, as well as find unknown angle measurements. When you know that the triangles are similar, you can find the corresponding sides by using the names of the triangle. So we're going to switch to highlighter and find our corresponding sides. Side AC corresponds to side DF. So we want to look at how the figures are named. The first letter and the third letter, AC, corresponds to the first letter D and the third letter F, DF, on the other figure that is similar. Side AB is the first and second letter. AB corresponds to side DE, the first and second letter named in the other triangle, DE. Side BC corresponds to EF. BC is the second and third letter named in the first triangle, and EF is the second and third letter named in the second triangle. So paying attention to how the two triangles are named, the similar figures are named, then you can use that information to help you locate the corresponding sides. Write a proportion comparing the lengths of a pair of corresponding sides. So we have AC and DE are corresponding sides, and we have BC and EF are corresponding sides. So we're going to be able to figure out the value of the unknown side by knowing that the shapes are similar. So AC has a value of 5 and DF has a value of 15. BC has a value of 3 and EF, we do not know the measure of EF, so we're going to use a proportion to solve to find the value of EF. So once we have our proportion set up with our corresponding sides, we're going to be able to solve the proportion as we're shown here. We have our cross products, of 5 times n and 15 times 3, and then we multiply, and then we divide to isolate our variable, divide both sides by 5, and we discover that n is equal to 9. So the length of the missing side is 9 inches. Corresponding angles of similar triangles have equal measure. So when we have our triangles named, triangle ABC is similar to triangle DEF. We can find our corresponding angles by knowing that the first letter is going to correspond with the first letter in the other triangle. So angle A corresponds to angle D. Angle B will correspond to angle E. And angle C will correspond to angle F. So since corresponding angle A since angle A corresponds to angle D is 35 degrees, so angle A will also be 35 degrees. So the measure of the unknown angle is 35 degrees. So we use the information of knowing that the two shapes are similar. We find the corresponding sides to solve for a missing side, and we find the corresponding angles to solve for the value of the missing angle. We're going to write a proportion comparing the lengths and widths of the volleyball court and the pool. Whenever we solve for missing sides, we have options on how we can set up our proportion. We can set up our proportion by setting up the proportion using between. What between means is that the ratio is made from one side of each figure. So when we are setting up between, we have the length of the volleyball court and the length of the pool. Length of the volleyball court, length of the pool. On the other side, we can have the width of the volleyball court and the width of the pool. So we can write our proportion, the between proportions, as 18 over 50 equals 9 over W. We could also have 9 over W equals 18 over 50. We could have 50 over 18 equals W over 9. And we could also have W over 9 equals 50 over 18. Another way that we can find and set up the proportions would be to do what's called within. Within, the ratio is made from two sides of the same figure. The ratio is made from two sides of the same figure. So we could have the length over the width. So that could be 18 over 9 equals 50 over W. So we want to match our highlights and see how the ratio is made from two sides of the same figure. And what's important is that you create your word ratio and you stick to it and make sure that all your numerators match and all of your denominators match. So for our within choices, for our proportions, we could have 18 over 9 equals 50 over W. 50 over W equals 18 over 9. 9 over 18 equals W over 50. And W over 50 equals 9 over 18. So when you write a proportion, there are 8 ways to write every proportion. When you write a proportion, the cross products will be the same if it is a correct proportion. Cross products will be the same. So let's look at our 8 proportions that we created. 18 times W is cross product. 18 times W. 18 times W. 18 times W. 18 times W is a cross product on all 8 of the proportions that we set up. 9 times 50 is also a cross product on all 8 of the proportions that we set up. So when you set up a proportion, there are 8 ways to set up the same proportion, and you will know that your proportion is correct if the cross products are the same. So whether you choose to set your ratios up using, to set your proportions up using between, where the ratio is made from one side of each figure, or whether or not you choose to use within, where the ratio is made from 2 sides of the same figure, it is not going to affect your final answer and your solving of the missing side. You want to make sure that you create a word ratio and then set up your proportion according to your word ratio. Let's try a problem. A student who is 4 feet tall stands beside a tree. A tree has a shadow that is 12 feet long at the same time that the shadow of the student is 6 feet long. So we want to find the height of the tree. So I'm going to create a word ratio. I'm going to use height over shadow. So I can choose for my first ratio to be related to the student or the tree. I'm going to go with the student since the student was mentioned first in the problem. So we have the height of the student is 4 feet tall. So the student is 4 feet tall. And the shadow of the student is 6 feet long. Then we want to look at the tree. The shadow of the tree is 12 feet long. So since my denominator is shadow, I need to make sure that I put the shadow in the denominator of the other ratio. And the height of the tree is what I'm solving for, so that will be my variable. That will be x. And now I will solve my proportion to find the missing information. So I will use my cross products. 6 times x equals 4 times 12, which is 48. I will divide to isolate my variable, so both sides will be divided by 6. 6 cancels on the left. I'm left with x. 48 divided by 6 is 8. So the height of the tree is going to be 8. You want to make sure that you set up your proportion so that you have your word ratio written and all of your numerators match. I chose to do height, so this is the height of the student, this is the height of the tree, and then my denominators are shadow. This is the shadow of the student, this is the shadow of the tree. So how you set up your proportion is going to be determined by the word ratio that you create. A photographer is taking a photo of a statue of Paul Bunyan, the legendary giant lumberjack. He measures the length of his shadow and the shadow cast by the statue. Find the height of the Paul Bunyan statue. You want to create a proportion. I would recommend that you do height over shadow for your word ratio, and then set up your proportion accordingly and see what you get. Good luck.